So, hi, hello everyone. How did your test go today? How was the test, everyone? Vignesh, Bhavna, Sravani, Omkar.
Good, sir.
It was good. Any doubts in today's test?
Yeah,
Any
sir.
question you want to ask?
Yes, sir.
Yeah, sure. Go ahead. Which one? Should I share the questions? There were questions related to continuity, I guess, right?
Yeah, sir.
Yeah, yeah. Just a minute. Let me open it. Okay. So have a look, guys. So this is what we have. The 15 questions that we had given you. How much time did you have for the test? How much time do you get for the test for the mathematics section? Anyone?
Yeah,
Okay.
I don't know
So yeah,
exactly.
you can ask. What? Okay.
Sir,
So, huh?
this,
Hmm?
not
Right.
this one, sir.
These
Yeah,
were
sir.
not the questions in today's test.
No, no, sir. I mean, my dot is not. Okay,
Ah,
sir.
okay, okay, okay. Not an issue. I'm scrolling down. You can just ask me whichever question you feel you have a doubt. Okay. Okay. Any doubt till now in this set?
Sir, can you explain the last one, sir? This one, sir.
This one? Cos x
Yes, sir.
minus cos. Okay. Like I thought this one would be okay. See, you have cos x minus sec x. So I can write it as cos x minus 1 by cos x, right? Right? So this can be written as cos square x minus 1, right? Cos square x minus 1. Do you agree? Cos square minus
Yes, sir.
1 by cos x. So what is cos square minus 1? It can be written as minus sine square x by cos x. Do you agree with this? Right?
Yes,
Yes,
sir.
sir.
The numerator can be written like this. So now I can write it as minus sine square x by cos x into x square into x plus 1. So x is tending to 0. So can you tell me where sine square x by x square will tend to? Where will it go to?
One,
One.
one.
Right, 1. 1. So if it goes to 1, is it an indeterminate form?
No, sir. No,
No, it is
sir.
not, right? I can just directly now put in my values. So if I put in my value x as 0, cos x is 1, x plus 1 is also 1. So minus 1, my final answer. Okay. Any doubts in the above question? Any doubts like in any of these questions? Hmm? Tell
So
me.
what about the cos
What
x
about
in the
cos x in the
cos x
denominator?
into in yes sir
Hmm?
cos x into
If x is tending,
x plus 1
see, x tending to 0, right? So where is cos x tending to?
1 sir.
Yeah. And what about x plus 1?
1 sir.
Yeah. So it is not an indeterminate form. So you just substitute your values directly. So minus 1 divided by 1 into 1. So your final answer is minus directly. Because now it does not remain an
Yes
indeterminate
sir.
form, right? Okay. Were you able to do this one? Uh, e raised to fractional part of x minus this square. Were you able to do this, everyone?
Yeah, sir. It will be 1/2.
1 by 2? Like 1 by 2 is not in the options. This is I, right? Okay, so you treated I as 1. So
Yeah, sir.
you think answer is 1 by 2?
Yeah, sir.
Like, do you get the right answers after you submit the test?
No, sir. I mean, I didn't see the answer. I mean, correct.
Okay, okay. Anyone else? Anyone else who has done this question? Anyone who has done solved this question? e raised to x minus this, the fractional part minus 1 by fractional part square. Anyone? No one? Anyone who has done this question in today's test? Okay. See, we are discussing about fractional part of x. Okay. Fractional part function. I have an integer I over here. So, Vignesh, do you know what fractional part of x means? What is meant by the term fractional part of x? What does it give me? Fractional part function. If I take fractional part of a, let us say
Decimal
5 point,
value.
great. It gives me the decimal part in that number. Okay. So if I'm talking about an integer I, okay, I is an integer, and I'm talking about I minus. I minus would mean a number that's just smaller than I. Okay. A real number that's just smaller than I. Can you tell me where will the fractional part of x tend to? I'm talking about a number that's just smaller than an integer. So it's something like I take 6 minus. Okay, I take 6 minus. So it is 5.999999, something like this. What will be the fractional part of this thing? Where will it tend to?
0.9.
0.999.
Okay, great. 0.9999 till infinity. So what is the limiting value of that thing? What is the limiting value of 0.99999
1.
till infinity? Great, 1. So the fractional part of x will tend to 1. So if you make over here the fractional part of x tend to 1, is it an indeterminate form? Is it an indeterminate form?
No, sir.
No, it is not an indeterminate form. So I can just directly put in my value fractional part of x tending to 1, and I will get my answer as e minus 2. And this is my
Sir,
right answer,
option 2.
right?
Yes, sir.
Yeah.
Yes, sir.
Vignesh,
Yes,
Vignesh,
sir.
Yes, sir.
Vignesh, do you get your error? Yeah.
Yeah,
Answer is
sir.
not I by 2. It is e minus 2. Okay. This is not an indeterminate form. Like I had specially put the question to confuse you. I knew if you forget what is fractional part function, you will mess up and you will make it tend to 0. If fractional part of x is tending to 0, obviously, then you can correctly say that this is an indeterminate form. Then either you can try differentiation or any other stuff, and then you will get your answer as half. Correct. But no, it is I minus. So fractional part will tend to 1. Okay, great. Pretty simple. Any question you didn't get? Just let me know once. I hope my screen is clearly visible. So this one, got it, everyone? This one, did you get it?
No, sir.
Okay, you didn't get it. Fine. So you've got f of x is sine 3x plus alpha sine x minus beta cos 3x whole divided by x cube. Okay, not an issue. So see, first of all, your denominator is tending to 0. Okay, and we are talking about a function that's continuous at x is equal to 0. So if a function is continuous at x is equal to 0, so that means its left hand limit should be equal to its right hand limit should be equal to the value at that point, right? And it is asking me what is the value of f of 0. So obviously, it is asking me to calculate the values of left hand limit and right hand limit. And obviously, they are meant to be equal. So basically, I will just take limit x tends to 0 and find the value of f of x. This is what it is requiring me to find. So see, the denominator over here is tending to 0. Do you all agree? The denominator over here is tending to 0.
Yes, sir.
Yes,
Yeah.
sir.
So
Yes, sir.
at x is equal to 0, where should my numerator go in order for my limit to be a finite value? See, obviously, my limit is a finite value. You can check in the options. All my limits are finite values. So I had
Yes,
told
sir.
you the logic before, right? If you have numerator divided by denominator, your denominator is tending to 0. So your numerator should also tend to 0 at that point. Otherwise, it will be an infinite limit. Do you all agree with this?
Yes,
Everyone,
sir.
we had discussed this before, right? I hope you all remember. Okay. So obviously, so at x is equal to 0, when my x is tending to 0, my numerator should be, what should be my numerator? 0,
Zero.
Yes,
right
sir.
everyone? Right. So you substitute your x as 0 in the numerator. So it is sine of 0. What is sine of 0? 0, right? So 0
Yes, sir.
plus alpha into 0. So that is also 0.
Zero.
Minus beta into
0 by
cos of
0,
3x is
sir.
1. Right? It should be 0. So what is my value of beta that I get over here? What is the value of my
Zero,
beta?
sir.
Beta
Zero.
is 0. Beta is 0. So this whole thing has already gone. Like it has already vanished. So now I am just left with f of x is equal to sine of 3x plus alpha sine of x whole divided by x cube. Do you all agree with this?
Yes, sir.
Yeah. So now, do you all agree that this is a 0 by 0 form?
Yes, sir. It's a 0 by 0.
Okay.
Yes, sir.
Okay, great work. So if it is 0 by 0 form, I can go for derivative. Should I go for differentiation?
Yes, sir.
Okay, then go. Let's go
Sir,
for it.
we can
So
remove sign now, sir.
no, no, no.
Sir, we
You
can
can't do that.
remove.
You can't do that.
Fractional.
Again,
There is a
again.
fraction.
Yeah, exactly. I think you messed up over here. If you do that, you will get infinity. You will get infinity. Your answer is infinity. Right? So pay attention about where we can use it and where we can't use it. Okay. So you've got sine of 3x. So it can be written as 3 cos 3x. Okay. Plus alpha cos x whole divided by 3x square. So again, your denominator is tending to, what is your denominator tending to? If x is tending to 0, where is your
0.
denominator tending to?
0, sir.
Okay.
Zero,
So what
sir.
should happen to your numerator? What should
0.
happen to your numerator? Great. It should also go to
0,
0, right? So you substitute x as 0. So when you substitute your x as 0, you get 3 cos of 0. Cos of 0 is 1. Okay. Plus alpha is equal to 0. So that means what is your value of alpha? Your value of alpha, guys? What is it?
Zero, sir.
No, it is. Just see over here. 1. See, 3 into 1
minus 3,
plus
sir.
Sir,
alpha.
it will be
Yes,
minus
sir. Minus 3.
3, sir.
Alpha is minus 3. Alpha is minus 3. Great work. So now I can write it as 3 cos of 3x minus 3 cos x whole divided by 3x square, right? So I can take out 3 common from this and cancel it with the denominator, right? Agree, everyone?
Yes,
Yeah.
sir.
So now again, so now it is cos of 3x minus cos x whole divided by x square. So I can do two things over here, like whichever you feel is beneficial for you. Either you can go for differentiation or you can do cos a minus
Just a second, students. There is some network issue at our end.
Okay. So everyone, we were there at, uh, you have got, it got erased. Yeah. So it was something like cos of 3x.
Minus cos x.
What was it? Can you tell me? Cos of
Cos
3x
3x
minus
minus cos
cos
x.
of x whole
Cos
whole
x is
divided by
cube. X cube.
x
X
square, I
square,
guess, right?
sir.
It was x, right?
Yes.
Yeah, x square.
Two
Okay,
x
x square.
square,
And
sir.
x is 10 to 0.
2x.
So again, like you have got two really easy options over here. Either you can go for differentiation or you can use cos A minus cos B. So which one would you want to do? I guess differentiation sounds good, right? So you can do it
Yes.
as
Yes, sir.
minus 3 sine 3x and plus sine x whole divided by 2x, right? So you can just bifurcate it. So it can be written as 3 by 2x into sine of 3x plus sine x by 2x. So this thing becomes half. This thing becomes minus 9 by 2. So minus 9 by 2 plus half. So minus 4 is my answer. Right, everyone? Do you all agree?
Yes, sir.
Now,
How it
like,
came 9 by
can
2 minus 9 by
3 into 3, right? You have got this sine of 3x divided by x. So it becomes 3. Okay. And the same way, like you can approach it through cos A minus cos B. And I want you to do it on your own. Again, like when you use cos A minus cos B, you will get two terms of sine, right? You'll get two terms of sine which are in multiplied with each other. So obviously they will have some x inside it, and you can just use it directly. So okay, chalo abhi kar hi lete hain. So can you tell me what is cos A minus cos B? Everyone, cos A minus cos B.
Minus 2 sine a plus b by 2 and into sine a minus b by
Minus
2.
2 sine A plus B by 2. Okay, great. And sine A minus B by 2, right? Right,
Yes,
Yes,
sir.
sir.
everyone? Whole divided by x square. So you give one x over here and one x over here. So it will be minus 2 sine 2x by x into sine x by x. This thing is 1, this thing is 2. So minus 2 into 1. So minus 4 again. I get my same answer, right?
Yes, sir.
Okay, great. So like how many questions did you attempt today? Can anyone tell me? How many questions anyone who has attempted the test today can you tell me how many questions did you attempt? No one. Fine. Let us have a look at this. So everyone was able to do this. It was really simple, I guess. Tell me. Anyone, any doubts in this? Like I can do it. Vignesh, Gayatri, Bhavna, Sravani, Ashrita, Omkar. Okay, great.
I-
So like I couldn't hear you. Can you speak again? Bhavna, Gayatri, Ashrita. Okay, so just tell me, you look at this function and it has a finite limit, 1 by 3. So its denominator is tending to 0. When x is tending to 0, its denominator is tending to 0. So can you tell me what do you infer about the numerator?
0.
0, sir.
And
It
okay,
will
great. It should also
also be
tend to 0.
tending to 0.
To 0. Okay, great work. So yeah, you can just substitute directly your value as 0 in the numerator. So 3 plus alpha times of 0. Alpha times of 0 is 0 plus beta into 1 plus ln of 1. What is ln of 1? Natural log of 1.
0,
Anyone?
sir.
Natural log of 1.
0, sir.
Great. Is
0.
equal to 0. So I got my value of beta directly as
minus
-3,
3.
right? Right? I got my beta directly -3. So I just substitute it over here. So I get 3 plus alpha sin x minus 3 cos x plus ln of 1 minus x whole divided by 3 times x. So again, is occupying the whole numerator. So I directly write it as 3x square, right? So like it is really simple now. It is 0 by 0 form. So do you think we should go for differentiation? Everyone,
Sir,
tell me, should we go for differentiation?
sir,
Tell me.
I don't
Ask
get how did
us,
you do the first step, sir? I mean, beta value.
Vignesh. Uh, okay, see, your denominator over here is tending to 0. Okay. Whenever you have numerator divided by denominator, we have discussed this, and you have got a finite value of the limit. Okay. Your value of limit is a finite value. So whenever you have this and your denominator is tending to 0, what should your numerator tend to?
0.
Yeah. So x is tending to 0. So you directly just check if your numerator should also be tending to 0. Right? Your numerator should also be tending to 0. That is what we will do over here. Great. So you check, you substitute x as 0 in the numerator. So 3 plus alpha into 0, that is 0, plus beta into 1 plus 0. So 3 plus beta is equal to 0. So beta is directly -3. Got it?
Yes, sir.
So yeah, we should go for differentiation, right? We should go for differentiation of this thing. So, okay, you have got alpha cos x, right? Plus, what do we have? Alpha cos x plus, tell me,
3 sin x.
3 sin x. How do you differentiate ln of 1 minus x? Anyone can tell me? Chain rule. Inside of
-6.
ln x,
1 by 1 minus
I have put 1 minus x. Tell
1 by 1
1 by
minus
1 minus x
into
into
1 minus 1.
into 1. No. Yeah, great. Because you needed to differentiate 1 minus x. So yeah, correct. Absolutely correct. So this is how you do it. Great. Whole divided by. Whole divided by. Tell me, 3x square. What is the derivative of 3x square?
6.
2x.
How much?
6
6, sir.
6
6.
x.
Okay.
6 x.
So again, if x is tending to 0, where is your denominator tending to?
0 sir.
So what should, so again, I can apply my same logic and shift it to the numerator also,
Yes
right?
sir.
So just check if my, for what value should my alpha will also be 0. So we have got alpha into 1 plus 3 into 0 is that is 0 plus -1 divide by 1 minus 0. And this thing should equal to 0. So alpha is equal to 1.
1.
So
1
alpha is
sir.
equal to 1 and beta is equal to -3. So 2 alpha minus beta. So it should be equal to 5. Agree, everyone? 2 alpha minus beta will be equal to 5. Right?
Yes sir.
Yes,
Oh, great. Great. So any doubt in the remaining two? Only two, three questions are left. Okay. Anyone?
Sir,
Ask, ask.
can you tell me the which one? 1 minute, sir. That
Hmm.
a into x
This
raised
one?
to x. I think the
Okay.
question is alpha.
Yeah, this one, right? Alpha x minus e raised to
Yeah, sir.
3x minus 1.
Yeah,
This
sir.
one, right? Okay. So you've got alpha x minus 3 raised to e raised to 3x minus 1 whole divided. So like it is really simple. Which form is this? Can you just tell me which form is this? Like when you substitute x as 0, which form of limit do you get?
0 by 0.
0 by 0, sir.
0 by 0, sir.
Great, absolutely correct. You get 0 by 0 form. So it is 0 by 0 form. So like you can solve it through many methods. Either you can go for taking the derivative, or either you can like divide your numerator and your denominator by x. Sorry, yeah, by x. So when you do that, you get alpha minus e raised to 3x minus 1 whole divided by x, right? My by alpha into e raised to 3x minus 1 whole divided by x. Is this correct, everyone? Oh, sorry. Okay, just a minute. Divide by x will not come over. Correct, everyone? Is this correct?
Yes, sir.
I am just dividing the numerator and the denominator by x. So this is what you will get. So like like now it's solved, right? Just make your x tends to 0 and you will get your answer. Right? Everyone? No? Okay. No worries. So we can do it. So tell me, limit x tends to 0, e raised to x minus 1 by x. What is it? We have discussed this. It is a special limit. What is this value equal to?
1. Log
1.
a base.
1. It is 1, right? We have discussed this. Like when we were
Yes,
discussing,
sir.
yeah. So it is 1. So can you just tell me, if x is tending to 0, what will 3x divided by 3x be equal to?
1, sir.
Great, 1. But it is 3x divided by x, right? It is 3x divided by x. So I can send this 3 over here, right? I just take this 3 out from the denominator and I can send it to the right side. So what will be the value of this limit?
1 by
3,
3.
sir.
No, it will be 3, right?
3, sir.
It will be
Yeah,
3.
sir.
So in the numerator, so first of all, just check the denominator. Where is your denominator tending to?
0.
Great. Your denominator is tending to 0. So obviously, if it is a finite value, beta should be a finite
How,
value.
sir?
Where should your denominator, right? I'm asking, where is your denominator
Yes,
tending
sir.
to?
Yes, sir. Yes,
So
sir.
e raised
0.
to 0, e raised to 0 minus 1. So e raised to 0 is also 1, right? E raised to 0 is 1 and 1 minus 1. So it is tending to 0. So where should your numerator tend to?
0, sir.
Great, 0. So you just substitute
Alpha
alpha
minus.
minus what? Your denominator is tending to 0. So where should your numerator tend to?
0, sir.
0, sir.
Yeah, great. It should tend to 0. So you have got alpha minus e raised to this thing minus 1 whole divided by x. So I can just check the value for x is equal to 0, right? So when you do that, you will get alpha minus. And now you have told me that this value, when x is tending to 0, this value is equal to 3.
3.
So in the numerator, you will get alpha minus 3 and its value is equal to 0. So you directly get your value alpha as 3,
3, sir.
right? You
Yes,
directly
sir.
get your value of alpha equal to 3. So now this thing will change to 3 minus e raised to 3x minus 1 whole divided by x whole divided by 3 into e raised to 3x minus 1. Do you agree, everyone?
Yes, sir.
Yes, sir.
So tell me, how should we solve this? Such a limit, how should we go for it? Now it is 0 by 0 form. How should I solve it? See, I know, like when you have got two functions in division and does any one of you know how to differentiate it? When two functions are in division, how do we differentiate it? Okay, so if you don't know that, you still have another option. You still have one option left if you don't know that. what is the option you have? You can use infinite expansion. So can anyone tell me what is the infinite expansion of e raised to x? What is it? The expansion of e raised to x. No one remembers. Vignesh, Gayatri. Tell. Tell.
Is
It is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on. Right? Now everyone.
Yes, sir.
Right? So what will be your infinite expansion of e raised to 3x? What will it be?
Three.
Like
1
in place
plus
of x, I can write uh, 1 plus
3x.
3x by 1 fact plus 3x whole square
3x
by 2
whole
factorial
square by 2 factorial plus
into
3x
3x
whole
whole
cube
cube.
by 3 factorial. 3 factorial.
Right? So now it is given to you e raised to 3x minus 1. So can I just take this 1 on this side and write it directly? I can do that, right?
Yes, sir.
This is correct, everyone?
Yes, sir.
Great. So just do it. And now it is in the numerator, it is divided by x also. So we will look at it later. So in the numerator, you have got, so first of all, let's just check the denominator. In the denominator, you have got 3 into 3x by 1 factorial plus 3x whole square by 2 factorial plus 3x whole cube by 3 factorial and so on. So this is what you have in the denominator. In the numerator, e raised to 3x minus 1 is getting divided by x. So if this whole thing is getting divided by x, your individually each term is getting divided by x. So you'll get
Yes,
3 by
sir.
1 factorial plus
Plus 3x
3x.
by 2 factorial.
It is 3 square x actually
3 square x by 2
plus
factorial plus 3
3
cube
cube x
square
x square by 3
by 3
and so
factorial.
on.
Yes,
Right?
sir.
Right? Everyone? Great work.
Yes, sir.
So obviously, like, what is 1 factorial? 1 factorial is 1. So
1.
these two will get cancelled, right?
Yes, sir.
So what is your least power? Least power in the numerator?
X.
1, sir.
1 x
1.
raised to 1, correct. And what about the least power in the denominator?
2, sir.
1
Your
only.
least,
Sir.
it is 1. It is 1. Great.
1.
So if you remember clearly, when x is tending to 0, you have a numerator and your denominator both as polynomials. So I had told you that you can go for the least powers. If x is tending to infinity, you go for the highest powers. So if x is tending to 0, you go for the lowest powers, right? We had discussed this, that you can just directly go
Yes,
for
sir.
that power of x. Yeah, we had discussed this. So using this trick also you can do, otherwise you can just cancel out an x from all of these. So that is also logical. If you cancel out an x from all of these terms, so again, you will be left with an indeterminate form, both in the numerator and in denominator. So going about that, so you can just take the least power. So minus 3 square by 2 factorial into x whole divide by, right? What about the denominator? 3 into 3x. Correct, everyone?
Yes,
Yes,
sir.
sir.
Yeah. So x got cancelled, 3 square and this got cancelled. So I got minus half. Right? Minus half. My beta is minus half. Right, everyone? Alpha is 3 and beta is minus half. So can you tell me what will be my value? Alpha plus beta?
3 by 2.
3, no, like alpha plus beta, right? So alpha is 3 minus beta. Alpha plus beta,
So
sorry.
5 by 2. 5 by 2.
By 2, sir.
Great. Great. 5 by. Correct. Okay. So, okay. So this is it. This one was also really simple. You just needed to take an infinite, a sum of an AP. Okay. So great. So we'll start today's lecture. Only 15 minutes are left. How generally do you get your scores of the test? Everyone who has attempted the previous week's test, have you got your scores? Tell me. I'm not like, you just tell me. I'm not asking you the scores. I'm just asking you, do you get the scores? Gayatri,
Yes, sir.
Omkar,
No, sir.
do you don't get your marks? How much you have scored in the test?
Yes,
No,
yes,
sir.
sir. I got.
Okay, you got. Great. And do you get the correct answers to the questions? Like, do you get to know which is the correct answer to any
Yes,
question?
sir.
Yes, yes, sir. Yes, sir.
After
Okay. Okay.
submission, it will be.
Okay. Okay. Great. So today we will be discussing about derivative. So till now we have completed our continuity. Like it was really simple. Okay. And now we will start about derivative. So like it is really simple and we have discussed this earlier also. So for example, you have a function y is equal to f of x. Okay. You have got a function y is equal to f of x. Here we have any point. Okay. Let us take this point to be any coordinate and I assume this coordinate to be x naught, comma, f of x naught. Okay. This is any point on the curve x naught, comma, f of x naught. I take a point. I take a point that's just next to this. Okay. So I can say it as x naught plus h. So can you tell me what will be the y coordinate of this thing? What will be the y coordinate? If the x coordinate is x naught plus h, what will be the y coordinate? Anyone? If y is equal to f of x, so if x is equal to x naught, so I can say that my y is equal to f of x naught. So now I am telling you that my x is equal to x naught plus h. So can I say that in this case my y is equal to f
Y
of
is
x naught
equal to
plus
f
h?
of x naught plus h.
Okay, great. F of x naught plus h. Great one. So now h, my h is a really small value. Okay, h is tending to 0. My h is very small value. It is tending to 0. So we have discussed this in the earlier classes when we were teaching to common syllabus to both common to JE and NEET students, that if h is tending to 0 and both of these are really close to each other, I assume that the line passing through both of these points
Is a
actually,
tangent.
great work, is a tangent to this curve. Tangent to this curve means a tangent to any curve means it touches at that particular point only, right? And it denotes the direction of the curve, right? But since
Yes, sir.
x naught and x naught plus h are really close to each other, since both of these are really close to each other, we assume that the line passing through both of these points is a tangent. Okay, so this is what the basic concept is. So now just going back a little bit, just moving back a little bit, I have got 2 points, x1, x2, and I've got 1 point, okay, x1 and y1, and I've got x2 and y2, and I've joined these through a line. Can you tell me what will be the slope of this line?
Y2 minus Y1 by
Y2 minus
Minus
Y1 by
Y1
x2
by
minus
X2
x1.
minus X1.
Great one. Great. So similarly over here, if I try to calculate the slope of this tangent, I have got 2 points. One point is x naught comma f of x naught. Another point is x naught plus h naught comma f of x naught plus h naught. So I have got 2 points, x naught comma f of x naught, and I have got x naught plus h into f of x naught plus h. So I can just directly use the concept again. So can you tell me what will be the slope of my line? My slope of my line will be f of x naught plus
f
h.
of x naught plus h minus f of x naught by h. H.
Great. So this x naught and x naught will get cancelled, right?
Yes, sir.
Right.
Yes, sir.
So just one more thing that I need to really apply on this, that my limit h should be tending to 0. Right? I should apply this.
Yes,
So
sir.
my slope will become f of x naught plus h minus f of x naught whole divided by h. Right, everyone?
Yes, sir.
Yes,
Okay.
sir.
So we have got this. We have got
0,
this.
0.
Yeah, this is 0 by 0 form, obviously. Like it has to be 0 by 0 form. Great. So this is what I get the slope, and this is what we call the derivative. Right? This is what we call the derivative of this function. So while discussing derivative, we come across two types of derivatives. One is the right hand derivative and one is the left hand. I know I have written it in the opposite way. So right hand, what does the word right hand mean? So I've got this point x naught comma f of x naught. So we talk about the point and we take the another point to be on the right side that we just did now. And now we get our slope as limit h tending to 0, f of x naught plus h minus f of x naught whole divided by h. Can we just think of the same way on the left side also? So I have got this thing. I've got x naught comma f of x naught. So can you tell me, can I take a point that's on the left side? Can we take a point on the left side also? Anyone?
Yes, sir.
Is it, yeah, like if we can take a point on the right side and calculate the slope of the tangent on the right side, obviously we can do it on the left side also. So can you tell me what
Yes,
will
sir.
the x coordinate and y coordinate be equal to? What will it be equal to if I take
X
a point
naught
that's on the
minus h.
great x naught minus
X
h?
naught minus
Good
h
work.
comma
F of
f
X.
of x naught minus h.
X naught minus h, great, comma f of x naught minus h.
F of x naught minus h.
Okay. Again, if I assume a line to be passing through both of these points, right? I am assuming again that this line is passing through both of these points. So I can again assume that it is a tangent.
Yes,
Right?
sir. Yes, sir.
Great.
Yes,
So
sir.
again, I assume that it is a tangent. So can you again tell me what will be the slope of these two? So again, you have got 2 points.
F
So
of
tell
x
me.
naught minus f of x naught minus h
H by X naught
divided
minus
by
X
x
naught
naught minus x naught minus h.
minus H.
Right. Great. So x naught minus h. This thing will again make it go to h. So you have got f of x naught minus f of x naught minus h whole divided by h. Right?
Sir,
This is what
it
you have.
will be
Huh? Tell.
yes, sir, correct.
Okay. Great. Everyone.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So this is what we call the left hand derivative and the right hand derivative. Okay. So in polynomial cases, again, we don't need to actually think of it much. In polynomial cases, all of these obviously they the left hand derivative and right hand derivative both are equal. So you can just think of it like you have a case wherein you have a polynomial f of x as something like a naught plus a1x plus something an x raised to n, something like this. So you choose any point on it. You choose any point x is equal to x naught. So if you take the left hand limit or the right hand limit, sorry, the left hand derivative and the right hand derivative, both of these will be equal, right? So you can just try it. So I mean, you will get f of x naught minus f of x naught minus h whole divided by h. And you can just take it f of x naught plus h minus f of x naught whole divided by h. So in both of these cases, you will get the same values. It is really simple to think. Okay, so let us just try this important case and check and try to prove it. So you've got f of x as x raised to n. N is any natural number or any real number. And it is asking me to find the both right hand derivative and left hand derivative. Okay. Okay, so first let us go for the right hand derivative first. So can you tell me what is the formula for right hand derivative? What is it?
f
F
of
of
F of
x naught plus h minus f of x naught divided by h.
Okay, whole divided by h. So obviously, like you know, what is the derivative of this thing? What is the derivative of x raised to n? The derivative
nx
of x raised to n.
NX, sir.
N
NX.
nx
nx. The derivative of x raised to n. What is it?
NX.
n into x raised to n minus 1.
Okay, great. So this is what we will be proving today. Earlier, when we were discussing about this, when I was teaching the common syllabus to both JEE and Neet students, it was not in their syllabus. So I had told you that after we discuss sequence and series, we will be discussing the proof of this thing also. So let us have a proof of this thing quickly. So I've got limit h tending to 0. So f of x naught plus h. So it will be x naught plus h raised to n minus x naught raised to n whole divided by h. Is this correct, everyone?
Yes, sir.
Everyone? Okay, great. This is correct. So again, like you have got x naught plus h whole raised to n, right? You have got x naught plus h whole raised to n. So you can think of it as you can take it, you can take x naught common out from this thing. So it becomes x naught into 1 plus h by x naught whole raised to n, right? So it becomes x naught raised to n into 1 plus h by x naught raised to n. Is this correct, everyone?
Yes, sir.
Yes,
Okay.
sir.
Okay, great. So 1 plus h by x naught raised to n. So earlier we had discussed the infinite polynomial expansion of 1 plus x raised to n. Does anyone of you know what is it? 1 plus x whole raised to n.
So is it 1 plus NX plus n into
Hmm.
1 minus n by 2 into x square?
Great, great. Correct. So in place of x, if I substitute h by x naught, you can see over here 1 plus h by x naught raised to n, right? So you can just substitute it over here. So you'll get 1 plus h by x naught whole raised to n. What will it be equal to? So it will be equal to 1 plus n into h by x naught
h by x
plus
naught plus
n minus 1
h
by 2
n h
In-
by x
into h
naught
by
whole
x naught
square.
whole square. Right, everyone?
Yes, sir.
Yes, sir.
Great. So let us see what we can do about it. So you have got limit h tending to 0. So in this expansion, you have got x naught plus h raised to n. So you can just see it over here. It is x naught raised to n into. So one, this thing. So I've got 1 plus n into h by x naught plus n minus 1 by 2 h by x naught whole square and so on, right? And the numerator you have got minus x naught raised to n whole divided by h, right? Everyone?
Yes, sir.
Okay. So if you send this x naught inside, so the first term will become x naught, right? X naught raised to n because it is multiplied by 1. So you can just directly cancel this 1 and this x naught, right? Like I'm just asking you to send this inside. Okay. So after you send it inside, you'll be left with nh x naught raised to n minus 1 plus n minus 1 by 2 h square into x naught raised to n minus 2 and so on, higher order terms, whole divided by h. And obviously limit h is tending to 0. So can you tell me what will be the value? Anyone?
0 by zeros.
Okay, great. It is 0 by 0. I mean, that is clear. It is 0 by 0. But you have an h in the denominator. You have this h over here in the denominator. And
Yes, sir.
your
It will
numerator
divide
also.
the numerator.
Yes, it will divide the numerator. So you can just directly do it. So when you divide the first term, your first term has a power. H and h will get cancelled. You will get n x naught raised to
Yes,
n minus 1
sir.
plus
Yes, sir.
the
Zero,
next
sir. All.
term when you do. Yeah, great. All
Yes.
remaining all terms will be 0. Why will all
Yes.
of these
Yes,
terms
sir.
go to 0? Because all of these has a power of h
Yes,
left in
sir.
them,
Sir.
right? So if I just directly make my h tending to 0, I get my final answer as n into x naught raised to n minus 1. Everyone
Yes, sir.
got
Yes,
it?
sir.
So this is my derivative. This is my right hand derivative of f of x is equal to x raised to n, where n is any real number. So now we have successfully proven it. Till now we were using this thing, but now we have proved it that this is how it exists. This is how the derivative we have got of n into x naught raised to n minus. Okay, everyone? Is this clear, everyone?
Yes,
So you can
sir.
just
Yes,
look back
sir.
at the proof and see how we have done it. And the same way, I want you to think of the left hand derivative also. So it is not much actually. Now you have got the procedure. So you just need to apply a little bit of logic. So it is f of x naught minus f of x naught minus h whole divided by h. So when you do this, you will get limit h tends to 0. You will get x naught raised to n minus x naught minus h whole raised to n whole divided by h. So you have got x naught minus h whole raised to n, right? So you can write it as x naught raised to n into 1 minus h by x naught raised to n. So just think how we can do it. So till now we were discussing about the infinite expansion of 1 plus x raised to n, right? It was 1 plus nx plus n minus 1 by 2 into x square and so on. So can you tell me what will be the expansion of 1 minus x raised to n?
1 minus nx. Sorry,
Great.
1 minus nx
Uh-huh.
plus n minus 1, n into n minus 1 by 2 into x cube, sir. X cube.
No, it will be x square and so on. Right? In place of x, you need to substitute minus x. So you can just directly get 1 minus x, right? So can you just tell me in place of x, what should I substitute so that I get this expansion?
H by x.
H by x naught, great. So in place of x, you can just substitute h by x naught in this expansion, right? So it will be minus n h by x naught. So over here, minus of minus will again make it plus. So this is your homework for today. Everyone got it? This is your homework
Yes,
for today.
sir.
Okay. To check the left hand derivative also. Again, it will obviously like convert to the same function. It is nothing to worry about. Okay. Let us just check one more case. One. So you have got f of x is equal to uh, x square plus 1 when x is greater than equal to 0. Okay. And you have got mod x plus 1 when x is lesser than 0. Or okay, let's just take it. It's just 1. Okay. A constant value 1 when x is lesser than 0. Okay. So first of all, I am asking you to check the left hand derivative and the right hand derivative at x is equal to 0. Can we do it, everyone? Can we
Yes,
do it?
sir.
Okay,
Yes,
great.
sir.
So let us go for the right hand derivative first. So going for the right hand derivative, you will have limit h tends to 0. You have got f of 0 plus h, right? Because your value of x is now 0. X naught is 0 now, right? Because I am asking you to check at x is equal to 0. So your x naught is directly equal to 0. So let us see how we can do it. So you have got x naught plus h minus f of x naught whole divided by h. So it is h tends to 0, f of 0 plus h, x naught is 0, right? F of 0 plus h. So it is directly h minus f of 0 whole divided by h. Can you tell me what is the value of f of 0 of this function? The value of f of 0.
1, sir.
Great. F of 0 is 1, right? F of 0 is 1.
Yes, sir.
Yes, sir.
First of all, is this a continuous function? Just asking you. Can
Yes,
you
sir.
comment anything about its
Yes, sir, it is
continuity?
continuity.
Yeah, great. It is continuous. How did you do that, Vignesh?
So, I mean, RHL equal to LHL equal to F of
Hmm.
0, sir.
Okay, great. So just you just check at the point x is equal to 0, right? Vignesh, you just check the value at
Excuse me,
x is
sir.
equal to 0. Yes, yes.
Yeah.
Ask.
How f
Ask
of
doubt.
0 equals to 1, sir?
Yeah. Because when x is greater than or equal to 0, it is x square plus 1.
Yes,
So
sir.
when I substitute x is equal to 0, it will go for this function x square plus 1. So x square plus 1. So x is equal to 0, right? So 0 square plus 1. So it will be 0 square plus
1.
1 is 1. Yeah.
Yes.
So I just wanted you to, uh, Vignesh, I just want to ask you one small question. Why did you only check at x is equal to 0? Why not at any other point? If I ask you the continuity of this function, why did you not check at any other point?
Sir, check
Sir, in the question they given
No,
at
no,
x is
like
equal to 0.
no, this is the differentiability. I am asking about the continuity. I'm just asking you a very basic question that when I asked you, is this function continuous? So why did you not check at any other point rather than x is equal to 0?
Sir, because they asked
sir,
only 0, sir.
Uh,
sir, the LHL
tell,
will
tell.
be LHL is
Hmm.
only 1, sir. Then LHL equal to F of 0.
Okay.
And
Like,
at
why can't okay, your question is your answer is partially
So
correct.
h
See,
is
just
the distance
uh,
between 2 points.
so
That is very less, na, sir. So,
no, no. What I'm
so
asking
it
is
tends to 0.
no, no. What I'm asking is when I asked you when I asked you to calculate to check if this function is continuous or not, you checked the LHL, the RHL, and the value at f of 0, right? This is what you did. Okay, so let us
Yes,
just
sir.
revise a little bit. So I'll just revise a little bit with you. So see, first of all, let us check about its continuity. Okay, the question was actually about LHD and RHD, but okay, let us. Okay, so checking about its continuity, you checked at x is equal to 0 if its LHL, its RHL, and its f of 0, three values are equal, right, Vignesh? This is what you did.
yes, sir.
Yeah. So my question is, why did we not check at any other point? Why did we not check the continuity at any other point? We could have checked that x is equal to 0.5 also, x is equal to -1 also. We could have checked that x is equal to -5 also. Like why did we not take any other value and we chose the value x is equal to 0 to check?
Sir, in the question, x is
Okay,
greater than or
okay,
equal
okay.
to 0 and x is less than 0.
Okay, now let us just forget this question also. Now I have reduced the question. You have been given this function, and I ask you to comment on its continuity. On all real numbers. Okay. I ask you to comment on its continuity on all real numbers starting from minus infinity to infinity. You need to comment on its continuity. So why is it that we are not checking any other point rather than x is equal to 0? Anyone can tell me? Why are we only checking the point x is equal to 0? See, it is like really simple to think of. At x is equal to 0, at x is equal to 0, it is, first of all, one thing is, it is changing. The function is changing. Do you all agree? It is changing from 1 to x square plus 1. So 1 point is change in function. That the function is, that the set of function is changing from one function to another function. So we check at x is equal to 0 to see if it is continuing or not in the same way. But what is happening when x is not equal to 0? Why don't we check at any other point? So
It is
like
not
it is really
continuous.
simple. Like it is continuous, obviously. The function is continuous, starting from minus infinity to infinity. Function is continuous. But we are not checking because you can check. Because you can just see if x is not equal to 0, either your x is lesser than 0 or your x is greater than 0. Both of these are polynomial functions. Everyone, do you agree? Everyone, x square plus 1 is a polynomial function, and 1
Yes,
1 can
Yes, sir.
also be treated as a polynomial function, constant function,
Yeah, yeah, sir, you have
yes,
said
right?
sir.
that,
Yeah,
sir.
and polynomial functions are always continuous.
Always continuous, sir. You have said that.
Yeah, yeah. So like I don't need to check at any other point rather than x is equal to 0. I can just directly say that it is continuous. Because if, see, I just need to check at x is equal to 0. I need to check at x is equal to 0 because the function is changing, right? It is converting from one function to another function. So I need to check if it is continuous or not. But if x is not equal to 0, either my x is lesser than 0 or greater than 0. In both cases, I have got polynomial functions. So I don't need to check. I don't need to check is it continuous or not, because both of these are polynomials. They will obviously be continuous. Okay. So now in the same function, let us check the LHD and RHD. So going for the right hand derivative first. So I hope all of you got this logic, that why we only need to check the continuity at x is equal to 0. Got it, everyone? Gayatri, Bhavna.
Yes, sir.
Yes, sir.
Okay, great. Okay, great. So RHD. So you have got limit h tends to 0, f of x naught plus h minus f of x naught whole divided by h, right? So again, your x naught is equal to 0. So what is your f of 0? What is f of 0 in this function? What is the
X
value of
square
f of
1,
plus
0?
sir. 1.
1. Okay, great. F of 0 is 1. Great. So this thing becomes limit h tends to 0, f of 0 plus h, right? F of 0 plus h. So it is f of h
F of h
minus f of x
minus
f
naught
of
1
is
0.
1 whole divided by h.
divided by h.
Great. So can you tell me, my h is tending to 0 and we are talking about the right hand side. So is my, okay, so we are talking about right hand side, right hand derivative. So I am talking about a number that's just greater than 0. Okay. So which function will it follow? Will it go for 1 or x square plus 1?
X square plus 1,
X
sir.
square plus 1,
Great.
sir.
It will be x square plus 1. So I'll get limit h tends to 0, h square plus 1 minus 1 whole by h. Do you agree with this, everyone?
Yes,
Yes,
sir.
sir.
Okay. So I have got limit h tends to 0, h square by h. It can be written as h. So what is my answer? What is my value?
0, sir.
0.
0, sir.
Great, 0. Now let us discuss left hand derivative also. So you have got limit h tends to 0. Okay. You'll get f of x naught minus f of x naught minus h whole divided by h. Right. So you will get limit h tends to 0. Okay. So again, your x naught is equal to 0. So again, f of x naught is f of 0. So it is 1 minus.
1.
Right. Now I just want you to tell me, I am talking about the left hand derivative. I am talking about a number that's just smaller than 0. Will it go for x square plus 1 or 1?
1, sir.
1, sir.
1, sir.
Okay. So my value of f of x naught minus h, that is f of minus h. What will be my value of f of minus h? What will it be?
Minus 1.
Minus 1, sir.
1 minus 1, right? 1 minus 1,
By
right?
h.
So what is the value of limit? What is this value equal to?
0 by 0.
Is it 0 by 0? Just think again.
0, sir.
It is 0 because the numerator is exactly equal to 0, right?
Yes,
Yeah.
sir.
So this is, so you have got your respective values of right hand derivative and your values of left hand derivative. Okay. So this is what this is okay for today. So just come revised with both of these concepts. And I want you, okay, so great work. So just one small thing I want you to do, one small homework. I want you to check the derivative of f of x is equal to sine x and f of x is equal to cos x. Okay, so how would you do it? You'll take limit h tends to 0. You'll take sine of x plus h minus sine x whole by h. And in this case, you will do cos of x plus h minus cos x whole divided by h. So in this case, in the left hand side, you will apply sine a minus sine b rule, the rule of sine a minus sine b. And in the right hand side, you will apply cos a minus cos b. And I want you to come up with the
Yes.
solutions tomorrow, right? After that, it will be really simple. Applying the limits is really simple. Because when you do a minus b by 2, you'll get sine h by 2. And over here, you'll also get sine h by 2. So sine h by 2 by h will directly give you half. So I want you to give it a try. Fine. Okay, so that's it for today. Ma'am, please end the class. Chandrika, ma'am?
Yes, sir.
Yes, ma'am, please end the class.
Okay, sir. Thank you, sir. Yes, students, we have class tomorrow morning from 5 to 7.